This is a solutions video to the beginning logarithm homework. I told you guys that you had to do it all because this is pretty basic. So let's start off. We were given a log equation and had to rewrite it in exponential form. The base stays the base. So here my base is 6, so the base is going to stay 6. My exponent is going to be 2, 36. The base stays the base and the other two things switch. So for number 2, this is going to be 289 to the 1/2 power is equal to 17. 3 is going to be 14 to the -2 equals 1 over 196. And 4 is going to be 3 to the 4th equals 81. All right, remember the base stays the base, so whatever's on bottom, base is on bottom, always stays on the bottom. And then the other two things switch sides. Another cool thing that I saw, I'll do that for this one. Let me write this over here. Found this online. I thought it was kind of cool. If you're in log form and you want to go to exponential form, E is for exponent. So what we do is we start here at our base and we make the letter E. So we start here at 3, then it goes to 4, then it goes to 81. So 3 to the 4th equals 81. Okay, just like if we go over to number 2, I'm in log, I want the exponent. So if I make the letter E, it goes 289 to the 1/2, 17. So that's 289 to the 1/2 equals 17. Nice little trick. Moving down, now we were given an exponential. We needed to rewrite it as a logarithm. So this is going to stay with the 64 as our base, and then the 8 and the 1/2 switch. So this is log base 64 of 8 equals 1/2. Base stays on the bottom, so the 12 is going to stay on bottom, and the 144 and the 2 switch. Base stays on bottom, so log base 9 of 1 over 81 equals -2. And then this is going to be the log of 1/12 of 1 over 144 is equal to 2. All right, and kind of the same trick, like above. Above we wanted exponential form, so we made an E. Here we want logarithmic form, so we can make an L. Now this one's kind of pushing it for me, but like if we look at number 5, I go through 64 and 8, and then you can come back up to 12, so it's kind of like a little block letter L. But even if you don't complete it, like if you look at number 6, if you make an L, you go through 12 and 144, 12 and 144, and then you're left with the 2, so that's what goes on the other side. Whatever helps you remember. Number 9, rewrite in exponential form. So this would be U to the V equals 15 over 16. Base stays on bottom. If you want, you could do the little E thing, but that's a little hard with the fractions. V to the 4th equals U. Again, you can make the E, even though that doesn't really look like an E. Number 11, let's see if I can make the E here. Bam, there we go. So 7/4 to the Y equals X. Number 12 is going to be 2 to the U equals V. Number 13 is going to be U to the -16 equals V. And 14 is going to be Y to the -8 equals X. The next section, we're going from exponential to logarithmic. So if you want, you can make the L. So in this case, this is going to be log UV equals -14. This one, if you want to make the L, you can. So it's going to be log base 8 of A equals B. Flip the page. Don't get freaked out if your base is a fraction. It's a little funkier looking, but it's still going to work the same. You can make your L. So log, L for log, log of the 1/5 Y is equal to X. Log base 6 of X equals Y. All right, if you don't want to make the L, remember, base stays on bottom. So my 9 is going to stay on the bottom, and then my X and Y switch. This is going to be log base b of 123 equals a. For this next section, we actually had to evaluate this, which, if you think about it, I really want to know, what does log base 4 of 64 equal? So I want to find out what this is equal to. So I'm going to put that this is equal to x, and I'm solving for x. Well, if I change this to exponential form, this means I'm doing 4 to the x is equal to 64. Well, boom, maybe these are those exponential equations that we've been practicing doing change of base. 4 to the x is 4 to the x. 64 is 4 cubed. So this means that x has to equal 3. For 22, I'll do it the same way. We'll set this equal to x. So that means that I'm doing 6 to the x is equal to 216. All right, if I do that, you can't change the base of 6, so you can mess around, see if you can get 216 to be 6 to some exponent, and actually you get that 216 is 6 cubed. So this is x is equal to 3. We can set this one equal to x. So this is 4 to the x is equal to 16. You can do your change of base if you need it, but hopefully everybody knows that this is x is equal to 2. Set it equal to x here. This is going to be 3 to the x is equal to 1 over 243. Okay, if you're getting 1 over something really big, hopefully that's an indicator that you're going to have a negative exponent. Okay, so the first thing that I would do, because negative exponents give us fractions, so the first thing I would do is I would change this to 3 to the x equals 243 to the negative 1. Okay, and then we can mess around and do some change of base. 3 is just going to stay 3, so we want to try and rewrite 243. When all is said and done, you end up getting that x is equal to negative 5. Okay, I don't have a ton of space, so I'm not actually going to show everything, but if you need help figuring out this change of base, you need to come see me. Alright, 25, set that equal to x, so this is 5 to the x is equal 125. Hopefully we're getting used to seeing this question. This is x equals 3. Okay, 125 is equal to x or 5 cubed. This one, set this equal to x. 2 to the x is equal to 4. Again, hopefully that's one that we all know. X is going to be equal to 2. Oops. 27, set that equal to x. This is going to be 343 to the x power is equal to 7. Obviously, I'm starting with 343 and I'm going down to 7. You are going to have a fractional exponent. Okay, and if you mess around with this, you end up getting that x is equal to 1/3. Okay, so in this case, what you want to try and do is 7 can't change, right? 7 is a prime. We can't rewrite it as something. We can't express it as a power to a power. 7 is just 7. But we can't write it as 7 to the first. So you need to mess around in your calculator and figure out how to write 343 as 7 to a power. Okay, just guess. Try 7 to the first. Try 7 squared. Try 7 cubed. Okay, you're going to end up getting 7 cubed. So this is going to be 7 cubed to the x is equal to 7 to the first. Now you've got an exponent of 3x equal to 1, so x is equal to 1/3. Alright, for 28, set that equal to x. So 2 to the x is equal to 16. You're going to get that x is equal to 4. For 29, this is going to be 64 to the x is equal to 4. And that is going to give you x is equal to 1/3. Very similar to the one above it. And for 30, set that equal to x, you're going to get 6 to the x is equal to 1 over 216. You're getting a fraction, so that should be an indicator that your exponent is going to be negative. This is just like number 24. Your first step should be to get rid of that fraction, rewrite that as 216 to the negative 1. Then mess around, try and get 216 as 6 raised to a power. When all is said and done, you should get that x is equal to -3. Going down. Okay, this says to simplify each expression, and I didn't really get the chance to talk about this, so it's good if you're paying attention. Whenever you have an exponent and a log with that same base, they cancel each other out. What I mean is, since this exponent has a base of 12 and this log has a base of 12, these two actually undo each other. They cancel each other, and you're just left with 144. The same thing happens for 32. You have an exponent with a base of 5, and then that's raised to a power that's a logarithm with the base of 5. So those two cancel each other out, and you're left with 17. 33, you have an exponent with the base of x, and then in the exponent you have a logarithm with the base of x, so those cancel each other out, and you're left with 72. And for 34, these are going to cancel, and you are going to be left with 20. Boom, baby, we are done.